Welcome everyone to this talk on Git and its possible successors. Thank you for choosing this talk. So in the next 45 minutes, I'll probably talk with you about a bit about Git, also a bit about Git's history, but also about the possible future. So to get started, my name is Hanno. I work at InfoSupport in Veenendaal here in the Netherlands as an IT consultant. A lot of my colleagues actually are C#.NET developers, but I have to admit I'm a Java developer mostly. Ooh, yeah. In Dutch we say in het hol van de leeuw, right? So, but I think version control is a pretty platform language agnostic subject, and I think we can learn from both worlds equally at the same time. So I think we'll have an interesting time whatsoever. And maybe if you folks keep it up, I even try to write some C# code if you would like to see that. Will certainly be funny for you, I guess. So I've worked as a Java software developer. I've also did some C#, but it was like a year or something, and it's over 10 years ago. So I think it was MVC4, so ancient stuff. Laughable, right? But I've been a software developer for almost 15 years now. And I remember when I was in college and I was learning to program, I was working together with my co-students. We used to send each other zip files with the programs that we written, and that was our version control by email. And I specifically remember when I started as a software engineer, I was really eager to learn a better way of version control. And I was thinking to myself, surely my first employer will teach me something very good about version control, because I was in university, we didn't have a really hands-on approach, we learned about hardware and stuff, and sometimes we did some programming, but we never learned really version control and software engineering techniques. So I was eager to learn this at my first employer. And at that place of work, they taught me version control by USB stick. And I didn't know anything, right? Just fresh out of school, so I was really eager to learn this. So at this company, I kid you not, we had a central computer, a laptop, in the middle of an open workspace. And each time you had finished your code, you would put it on a USB stick, walk over to the central laptop, put it in the computer, find the code base, try to integrate it in some way, merge some conflicts, because there would always be conflicts, and then save the files and go back to your workstation and start working on another feature. Actually, it was even as bad as if this workstation, this laptop, was actually a resource in our Exchange server. So you had to book the integration laptop in our Exchange system. And also there were blocks of 30 minutes each, so you couldn't overrun your block because another developer would be waiting. So if you failed merging your changes, you had to revert it back and book another block or a double block or something. Yeah, tragic, right? Tragic. So fast forward 15 years again. I have left that employer a while ago, and I've learned lots of other stuff, and I've gained some experience with version control systems. So I've worked with CVS even, Subversion and Git. So in the Java world, we're not really big on Team Foundation version control. I'm quite sure some of you folks have used that. Maybe show of hands. Team version foundation, maybe still, or maybe Git right now. Yeah, most of you. Okay, oh great. So I really dove into this version control subject because I teach a course about it at InfoSupport. So we are a consulting company. So if people start out with us, it's very important that they learn all kinds of IT skills, hands-on skills, to be able to work at their projects. And so we offer a wide range of courses, object orientation, automated testing, continuous delivery, containerization, and so on. And one of the courses is about version control with Git. So this is one of the courses I teach. A one-day course, and I just teach how to use Git as a developer. So most of the people that come in either have some experience with Subversion or Team Foundation version control, or they have used Git, but only in a graphical user interface way, right? Just clicking and change sets. And we try to teach Git by using the command line to really get into the depths and to make sure that you know everything about Git. And I always say at the end of the course day, if you really want to return to use your Git UI. You're free to do that, of course, but at least now you know what Git is doing underneath. And also what we talk about is how does Git compare to previous version control systems. And this is one of the slides I show at the course, actually. It displays which version control systems have emerged until now and when they became available. But it also tries to put this into perspective by comparing the version control system to the most modern mobile phone known at the time. So, for example, Subversion is right here. And it corresponds to the indestructible Nokia 3310. Who had one of those? I had one of those. And it was truly indestructible, and the battery would last for like a month or something. It's insane. CVS, by the way, one of the very first version control systems relates to this one with the power block, so both are obviously ancient. Now, when I talk about this slide at the Git course, I usually focus on the events of the year 2005, because in a very short amount of time, a lot of new systems emerge, right? Git is one of them, but also Mercurial, Bazaar, Darks, TFS actually. So a lot of systems emerge at the same time. And it really stands out because in 2005, 5 new systems emerged. Whereas before that, it had taken 9 years, so starting from 1992, for 5 version system control systems to appear. And in this year, there were 5 at the same time. So does maybe anyone happen to know why this happened in 2005? Did something impactful happen in that year? Well, it has something to do with BitKeeper, actually. Yeah, very good. So, BitKeeper was a proprietary piece of software, but it was the only distributed system at the time. So all the other systems were classic client server, and BitKeeper was distributed, one of the very first ones, actually the very first one. And it was used by the Linux kernel team at the time, so the start of 2005. Which is kind of strange, because Linux is like the open source advocate of everything, right? So why would they use a proprietary system? Well, actually, the Linux team got a special deal. They could use BitKeeper for free in exchange for some metadata and an agreement for the contributors to not work on competing version control systems at all. So that was the deal for them to continue using BitKeeper. But BitKeeper informed the Linux kernel development team that the deal was off, and they would have to start to pay to continue using it. And that was, of course, against everything the Linux platform team stood for. So Mr. Linus Torvalds decided to start writing his own version control system. That became Git afterwards. But a lot of other open source efforts were started due to the very same reason. So that's why Mercurial, for example, also emerged in the same time span, and why it also looks quite the same in a lot of its aspects. So I thought this year really stood out in the graphic. But not everyone thought so. So at the end of one particular course edition, a student came to me with a question, and she said, I really like Git, but it really felt strange to me that nothing seemed to happen after 2005. And that never really occurred to me. I only focused on this whirlwind of new version control systems, but she was obviously right. Nothing ever happened after 2005. So I said to her, well, I'm quite sure Git will be around for a while, probably even forever, but I didn't really literally say that, of course, because of what IT software product will ever remain forever. I mean, we used to think that Internet Explorer will be around forever, and just last week it was in the news that it is finally end of project for Internet Explorer. So actually, I really wanted to find a good answer to the question of this student, and I started an investigation, and the investigation turned into a conference talk, the talk you're attending right now. So let's just find the answer to this question together, shall we? Will Git actually be around forever, or will something else pop up and be better or become more popular? And I can't be sure, but I can tell you what I found out during the research. So. Now, whenever I hear somebody say that some product will probably be around forever, it immediately reminds me of this quote, which he probably didn't even say exactly like this. Maybe he added "for now" to the claim, I can imagine. But I think he did because Mr. Gates knows very well that in the computer industry, change is the only constant. This idea has been valid in our industry for as long as I can remember. And if you think about it for a second, you can come up with lots of examples. I mean, requirements change, priorities change, dependencies change, or if you work in front-end, browser behaviors change. So change is the only constant in our industry. So no, Git won't be around forever. It might be around for now. It might even be around for a few years, maybe a decade, but eventually there will be a successor. Right now we don't know which one it will be, but there will be one in the end. And I think if you want to know which one it will be eventually, you have to think about why did become the big thing in the first place. And throughout this talk, I will point you all to a few ideas that are useful to our prediction. So I call these ideas prediction variables. At the end of the talk, we'll use these variables to make the final prediction. And I think we can discover the right variables quite easily by focusing on Git, the current big thing. How did Git become the big thing in the first place? Well, these are the main features of Git, and of course, you may all know them. It's distributed like Bitkeeper. You can commit often and push only once. It's free, it's open source. This is unlike Bitkeeper, of course, which was the whole point of Linus Torvalds creating it. And it's fast. So Linus Torvalds said, everything you ever do on a daily basis should take less than a second, which is why branching, for example, it's been optimized for branching. So in the CVS age, developers were afraid of branching because it would create literal physical copies of a directory structure, which was slow. And with Git, it's just a reference to commit, and it's fast. When he was developing Git, actually, Linus Torvalds said, one of my guiding principles is, what would CVS now do? WWCVSND. And if I'm in doubt of a certain decision, just make the exact opposite decision of what CVS did. Yeah, apparently it worked out. So I think one of our prediction variables should be killer features. And by killer features, I mean two things. New features that have never been seen before, like fast branching, for example, or similar features implemented differently, where a similar feature has been implemented in a radically different way to distinguish it from any competitors. Git is a great example of killer features because it was designed to be the opposite of CVS in many aspects. Now here's some information on how Git became the big thing. Now there's a lot of significant information in this chart. For example, one of the things that stand out to me is that GitHub started rising rapidly after Git started rising rapidly after GitHub was launched. And actually, once Bitbucket said we support Git, even also, the growth went more up actually. And Mercurial, which was the version control system that was supported by Bitbucket, started declining after Bitbucket said, hey, we will support Git also. So, makes a lot of sense. Well, I have to point out that this data is an approximation, of course, of the real usage. I mean, how many people are using Git or Mercurial or Subversion or Team Foundation? I mean, you can't really measure this. So this is aggregated data. It says on the bottom of the chart, Google Trends, GitHub, Atlassian, GitLab, which is also the reason why I never found an updated version. But maybe for a future version of the talk, I would really like to do a survey of my own. I mean, what are you using right now? So if we are doing any predictions based on this, they will also be estimates. They will be approximations. So I can't really tell you for sure which will be the successor, but I can tell you some sense of general direction. TFS is still called TFS here, but it's now Azure DevOps Server, of course, and the version control system part is TFVC, which you can also choose if you are creating a repository. So the available source code hosting options is also quite influential for its popularity. So this should be our second variable, hosting platform support, because Git became very popular due to GitHub and Bitbucket and GitLab. So it's very significant, I think. And open source community support, I think, is also an important one. lots of hosting providers primarily offer private repositories, but if they are offering public ones, then this can create more popularity for your version control system. And I think Git became so large because the open source support was very good. So let's try to come up with a first prediction and then adjust it along the way, right? And I can only think of one approach at this stage, which is extrapolate from incomplete data. There are two types of people in the world why you know this joke, right? So if we take the existing data that we have right here and we would extrapolate it, so just continue the trends that we see right here. So Git is on the rise, Subversion is declining, Mercurial is declining, but a bit less than that, and TFS and CVS are kind of staying constant. Well, then you can come up with this. So these are the percentages that I wrote down for 2010 in the chart. And the first time I did this talk, I would add 10 years, but we're now like 12 years ahead, so I'm adding 11 years. So if we would extrapolate the data, Git is on a rapid rise, Subversion is declining, Mercurial is declining, skip another one, then we would end up somewhere here. So Subversion has been diminished until 8%, Git is on a rapid rise, of course, Mercurial has declined, and the other two, well, CVS has been diminished to less than 1%, and TFEC is like the same. If you would extrapolate again, then I think you would arrive at about this. So I could say, there you have it, Git will stay on top. Thank you for your attention. Enjoy the rest of your conference. But that would be a joke, right? Because the problem is I haven't included any new product. So a lot can happen in 10 years, right? So if a brand new product comes along, takes the market by storm, we have to account for that. And this is exactly what happened during the browser wars. Now, when I was in college and I did, version control by emailing stuff, I also did a talk on the browser wars for one of my courses. In this college talk, I tried to predict what browser we would use 10 years later in time. So the talk was actually quite similar to this one, apart from the fact that my slides back then looked very different. This was actually one of my slides. It's in Dutch, but that's not the worst thing. It's a retro slide deck, right? The obnoxious headers and footers, everyone did it like that back then. The background gradient, what's up with that? Nobody does that anymore. Page numbers at the bottom. When were page numbers ever useful, right? Never. It's just horrifying stuff. Maybe slide deck designs are like fashion, If we wait another 15 years, we'll be popular again. I'm not sure. I wouldn't count on it. But apart from the fact that the slide causes your eyes to sting, it also shows that the Internet Explorer browser family was very dominant in 2005. Almost 90% of all internet users use an IE browser. Now, in this college talk, I predicted 3 things, and 2 of them actually happened in the end. So I've got some experience doing this stuff. These were my predictions. I said in this talk, in 10 years' time, IE will be surpassed as the top browser family. Firefox would also surpass IE, and I also thought that Firefox would become the top browser. Only the last one never came true, but the other ones actually came true. And I've grabbed some data, which is where you can see that actually my predictions were correct in a sense. So the Internet Explorer family is the light blue line right here, and this was the point in time where it was surpassed by, in this case, Google Chrome. So they weren't the top browser family anymore. And also Firefox. What was the prediction again? Sorry, I forgot. Firefox would surpass Internet Explorer. Well, Firefox is the black line, and this is the point in time where it surpassed it briefly. But it did, so... so Firefox never was actually the top browser, but I didn't really know that Google Chrome would start out and be the top one. Actually, I read an article last week that Google Chrome is even further up the charts right now, so you could ask the same question again, will they stay on top or maybe go down again? I'm not really sure, but I'm not here to repeat my college talk. But the only thing I have to add that this Firefox being the most popular browser took 11 years, because as you can see, it's 2016 here, and I did the talk in 2005, so the prediction was 11 years, not 10. But I came close. I sort of was right. So, maybe I'm quite good at this stuff. I'm not sure. This is the only thing that I can show you. Now, the reason I was quite confident someone would surpass Internet Explorer is because a mechanism that is called the law of the handicap of a head start, in Dutch, de wet van de remmende voorsprong. This is actually quite an old term. Jan Romein published about it in his essay, The Dialectics of Progress. The law suggests that individuals or groups that start out ahead eventually are overtaken by others. The head start, which is an advantage at first, ultimately becomes a handicap because when a society dedicates itself to certain new standards, and certain standards, but the standards change, then it becomes harder for the leading group to adapt. So to put this into perspective for browsers, one of the features of Firefox and Chrome was tabbed browsing, for example. And the old Internet Explorer browser family took a very long time supporting that. They were having trouble adapting to the new standards that society demanded. So actually, I think this is another prediction variable, the handicap of a head start. So if you're on top right now, it stays harder to stay on top. So if we're going to do a prediction, the product that is currently on top will suffer from this handicap the most. Okay, let's return to the version control world and see which new products we should examine. Well, actually, I've got 2 products on this list right here, but in a longer version of the talk, I talk about 3 products. I have to address the third one very shortly. So the third one is called Plastic. And in the longer version of the talk, I talk about Plastic for a few minutes, quick demo and stuff. But Plastic is a specific version control system focused on game studios, where contributors work with graphics and other binary files. So it focuses on making sure that people who are not software developers can also work with version control comfortably. And they have all kinds of features like the image diffing or 3D model diffing, so very graphical oriented. And also it's proprietary software, so they haven't heard the BitKeeper story yet, probably. A nice addition to the market, I think, as it fills a niche, the gaming industry, but it's a closed source license, so I don't think it will replace Git in the end. And in this shorter version of the talk, I left the demo out completely. So we're going to look at Fossil and to Pijul, 2 new systems. So Fossil, let's talk about Fossil first. The features of Fossil, well, it does distributed version control like Git, so comparable to Git. It has integrated bug tracking, wiki, forum, and tech nodes. So it's like an interface that you can start up. Actually, the Fossil websites runs on the same interface as you can get with your entire repository. This is the built-in web interface that I talked about already. It has 2 different merge modes, an autosync and a manual merge mode. So manual merge looks more like Git, where you just decide when you want to merge something, and the autosync does this automatically for you if you want. It can show descendants of a check-in, which is quite unique because Git only knows its ancestor, never the descendants. So it can show both sides of the commit, actually. And it also supports operations on multiple repositories. I really like this feature because in Git, this is quite of a pain. What if you have 10 or 12 repositories? You want to pull them all. You can't really do that. You can create a custom script or something yourself, but nothing native, right? And finally, it has a preserve all history philosophy, which means that there is no rebase in Fossil. So you can't do, well, Git rebase, Fossil rebase doesn't exist. So history that has been recorded will always remain history. Why would it be called Fossil, right? It would be a very stupid name for something that has rebase. Yeah. So some quick facts. It's written in C and SQL. Actually, it has been written specifically to support development of the SQLite project. So SQLite is developed by using Fossil. And you can also get free code hosting. The hosting platform is called Chisel. And one of the perks of SQLite being a project that runs on Fossil is that Fossil just needs an SQLite database to generate static HTML. And this is the only thing you need, actually. So code hosting, that's great, but any hosting provider that will help you, that supports an SQLite database, and I think all of them do, because that's just a file, right? So any hosting space provider could help you host a repo if you want. Like I said, you could just host it yourself if you want. It uses a relational database, the SQLite version. It's stored in a single SQLite database file, and like I said before, it contains relations between check-ins to be able to produce both ancestors and descendants of a check-in. Actually, you can think of it like GitHub in a box, because on your local machine, it has all these things like ticketing and a wiki, embedded documentation, a forum, and you can all call this up by using the fossil UI command. I think because there's no need to use any third-party products here, it's well suited for startups and maybe small-scale projects like SQLite, because the SQLite team is actually a very small team. Last time I checked, only 4 developers on that project. I don't think it's really suited for large-scale open-source development like the Linux kernel, where thousands of developers are working on the same code base and they're also geographically isolated. So for small-scale projects, I think it's well suited. So let's do a quick demo of Fossil, okay? To show you how it works. Okay, so we're in an empty directory right now. The first thing I want to do is create a directory. And then I have to create a repo file. Well, Git always uses a hidden directory embedded in the repo directory, and Fossil uses a separate file, the SQLite file. So I always like to create that outside of my repo directory, because otherwise it would get checked into source control, and that's the only thing you don't want. So, and to create it, you just run fossil new demo.repo. And then it tells me this is the admin user, this is the project ID, there's a password on the screen. That's great. Then we tell Fossil, then we just change directories, and we tell Fossil to open the repo. So by calling Fossil open, we just link this directory to the repository file. And now we're ready to do some coding. Right, who wants to see me, a Java developer, write some C# code? Or yeah. I can also use Java if you want. Yeah? No? Oh, yeah, I was counting on this answer already. I've installed the .NET framework last week, so that's a whole new thing, right? I've learned that if I run this, it will generate a .NET 6 starter project or something. It actually restores something, so maybe it sees that I've done this before. Not very important. So when I return to my VS Code, yes, Java developers do use VS Code. This is what has been generated. So I think that's great. Why do I need the C# extension? Is that important, or? Not now. The only thing I just want to show you is how we add this file, right? So what we do is, in what directory are we? We're in demo, so we just say fossil add dot, which adds a lot of stuff. So these are, I think, a lot of files you want to ignore, right? Yeah, the debugger. Yeah, I remember from my C# days. I'm not going to spend time drafting an ignore filter, but you can do it. It works just the same as in Git. So I'm not going to bore you with that. Just the important parts. If I would want to know what my changes are right now, I just ask fossil changes, and it will give the same output as the one I just gotten. Now let's create a commit. It's called commit in fossil as well, and I'll tell it initial commit, which is a very bad description. Oh, this is so the .NET command did crlf things, and I'm on a Mac, so let's convert everything. Okay. Now I want to show you the fossil UI, because this is the stuff I'm really excited about. I think it will be right here. Oh, the beamer seems to be a bit bad contrast, so I'll just zoom out, zoom in a bit. So this is what gets generated. I probably have to give it a name, but there are all kinds of config files, and there you can check that out. This is the timeline, and it shows you a graphical representation of the timeline. Here you can see it. So this is my initial commit and the user, and you can also see the files that are, these ones. So we didn't want them, but they're in there anyway right now. So it's a nice graphical way of doing stuff. Actually, if you go to the Fossil website, I think it's fossilscm.org. It looks exactly the same, right? So it's just running the same stuff. Oh, there's a lot of more content, of course, but just running on their own interface. Okay, so let's create a new feature here, right? And I want to use a different branch because that makes the graph look a bit more interesting. So let's say fossil branch, new feature current. Feature is the name of the branch, current is the default branch, and this just tells it to create a new branch. So it created a new branch right here, and it activates it directly. Now let's write some actual code, right? Where's my VS Code? So I want to generate a random number. I really like that. So let's just define a static int random. Remember the uppercase here, right? Do I really have to put the brace on the next? Yeah, oh, this hurts my heart, but okay. Yeah. And what do you do when you need a random number? You roll die, right? So let's roll die. Oh, it's quite far. It returns 1 chosen by fair dice roll. Always random. Doesn't really matter what I type here, but you get the gist. So let's add this file again to our fossil repository. Fossil add. We'll actually add everything. Fossil commit -m implement. Oh, sorry. Yeah, it's quite convenient that Git only is a 3-letter keyword actually. Implement random. Again, this one. Okay, there it is. Let's check this UI again, just because we can. Well, here it is. It's created a new branch. Well, actually, I forgot to put it on the branch. That's great. So we created a new branch, but this is still on the current. That's great. But the only thing I wanted to show you is this, which is actually the most important one. So if I open this commit up, it can show me the ancestors. Of course, the ancestor is the initial commit, nothing fancy there. And Git can also show you this. But the descendants, Git cannot show you this. And it knows that there are 2 descendants here. So that's really great. Oh, actually, I may have to open this one for that. No, if I open the initial commit and click on descendants, there are 2 descendants. So this is because it's a relational database file. It can show you this stuff. So let's finish by providing an actual random implementation because it really hurts me to do it like this. So let's define another method, actually random. Well, pseudo-random, of course, but a lot better than the other one. Oh, yes, on the next new line. And let's just return a new random, no, not random access. And I believe it's called next. It is called next, and the bounds are inclusive. That's quite nice. In Java, it will be exclusive, actually. I have to. Is it exclusive? Yes. Are you sure? Oh, thank you. I was wondering why I never got 6. Okay, that sorts it out. Yeah. Well, it helps that I told you that I don't know C# at all. Then this becomes quite funny again, right? Okay, and let's just test it out for a bit. So I've learned last week that I can do .NET run and it will run it, hopefully. Not sure about 6, 4. Well, it seems to be working. We'll have to write tests, of course, but not now. So there you have it. We've created a random implementation. We did some commits with Fossil. I could add this to a commit again, but I think the basic stuff I already showed you. So let's return to the slides again. Mirror it up. There we go. Just have to click here. Okay. Back in business with the slides, I guess. So, well, are there bad things? Well, of course there are bad things. Dealing with large files and large commits is kind of iffy because it's all stored in one single database file. So if you're adding large files, you will get a large database file, which could get a little nasty. So if you're interested in it, there's a good blog post about dealing with large files and large commits in Fossil. And if you would compare it to Git, I really started thinking about the right tool for the job because Fossil seems more suitable for small-scale closed-source projects than Git. Why are you all using Git? A version control system that was designed to support a globally developed open-source project like the Linux kernel. Are all projects like that? Is your project like the Linux kernel, or does it look more like SQLite with a small team? Not 5,000 contributors, but 4. No global engagement, but maybe on a personal level. And the workflow at Git is very much built on hierarchy because Linus doesn't trust many people, only his lieutenants, and the lieutenants trust a few people, and that way he builds an open source hierarchy. Whereas with Fossil, if you work like 4 or 5, 6 people maybe, you can trust them with a code base, and you don't need this hierarchy workflow. So, well, surely something to think about. I won't tell you everything to switch to a different version control system, but it seems like it's better suited for small-scale development. Okay, then we have to talk about Pijul, and the first thing I have to tell you is why this is such a difficult to pronounce name. Well, because it's a Spanish word, and it's actually the name of a bird that does collaborative nest building. So they really liked the collaborative stuff of this bird species, and that's why they called it Pijul. I think they have experimented with renaming this one, but then, well, they really like the fact that this is very uniquely Googleable, I guess. So they stuck with the name ever since. Pijul is a version control system that looks actually a bit like Darks. Has anyone ever used Darks before? Yeah? What did you think of it?
I didn't use it that much.
Okay.
Because Git was already
in
the popularity contest.
Yeah, it did. So Darks is also patch-based, just like Pijul, whereas Git is snapshots-based. I'll go into this in a few minutes, but Dark was actually in the VCS popularity graph I showed you earlier, and it never really got popular because although it was batch-based, it also was very slow, so it didn't really perform well. So Pijul is trying to fix the performance issue of Darks. There's a lot of mathematics to their patch-based design. There's a lot of documentation on their website if you're really interested, but it would be a bit too much in depth to include in the talk. However, there's a lot of math involved actually. So like I said, it's fast because it tries to fix this Darks performance issue. And one of the features I really like is interactive recording. So if you've added a few things to your change and then you want to record them, you can leave some stuff out if you want and save it for the next patch. Some quick facts: it is written in Rust. That's quite a low-level language, so their performance is quite good, better than Java, for example. It has been bootstrapped since 2017, so this means that they use their own version control system to keep track of their version control system, which is quite nice. I always like bootstrap projects. For example, if you would build an IDE and use your own IDE to build, well, I guess Visual Studio is the same way. IntelliJ by JetBrains is also the same. So they eat their own dog food, right? And you can also use free code hosting. This is called the Pijul Nest. So it's just like GitHub or just like Chisel. Host your own repositories. And let's talk about this patch-oriented design, because by contrast, Git doesn't store any patches. Git stores snapshots of files, just different version of files, and computes the differences. When you ask a Git diff, it will compute the differences on the fly. A patch is an intuitive atomic unit of work, and it focuses on changes. So a patch stores insertions, stores deletions, stores modifications, but it doesn't store 2 versions of the file. So this is quite a different way of doing things. applying or unapplying a patch never changes its identity. Whereas with Git, if you apply something or if you cherry pick a commit on another branch, its identity changes altogether. Internally, its content will be the same, but its hash will be different, for example. So it's like a copy. It's like replayed. The end result of applying several patches is always the same, regardless of the order in which they were applied. Well, of course, there is the concept of dependence. So if you apply a certain patch and there's a dependent patch next to it, it has to apply that one first and then the other one. But in principle, this is still correct. Oh, like I said, Pijul keeps track of dependent patches. So for example, if you have a patch that creates a file and a patch that adds a line to the file, if you just want to apply the patch that adds a line to another channel or bench or repo, Pijul will see that you first need the patch that's underneath it, because in that patch the file was created and you can't add a line if the file's not there. So that's how that dependency works. Pijul doesn't do any merges or rebases. Applying patches is just cherry picking, but with the identity restored. So the identity is always the same. So it doesn't need merges or rebases, actually. Everything is just replaying patches. So this is how you could compare them, Git and Pijul. So in Git, if you would have this version of the file and then you would change the order or maybe, just another word, you just store these versions, and this is the final result. Whereas in Pijul, you start with this one, and you store an addition or a deletion until you also arrive at this one. So you arrive at the same versions, but the way the differences are stored is very different. I have a quick demo, but I also have to keep track of the time, I see. So I try to do the best demo I can in like 3 minutes. If you're interested and you have some time after the break, I'll just end the session for everyone, but then you can hang around a bit more if you're really interested. So I can do a larger demo for a smaller crowd if you want, but I can also imagine you really need a drink after this. So suit yourself, I guess. But I have a quick demo. To view how the Pijul patching works. So let's mirror again. So I have a Pijul repository ready right here. Actually, it's in a Docker. It's in a Docker container. So I will share in the final slide the Docker file. Also, the slides will be in a Pijul repository, by the way, at the Pijul nest. So there will be a link on the final slides, and you can also download the Docker file there, and you in a very low level way, you can just try it out. So that's a good tip, I guess. So if we want to create a Pijul repo, we say to Pijul init and give it a name, demo. We see that the demo folder has been created. Let's create a README file like this. This repo contains beers and movies, because that was the example that I prepared, that are important to us. Well, they are. Oh, we have to pipe it to a file, sorry. There we go. So we've got a README MD right here, and just we say Pijul add README MD, Pijul record -m initial patch. So no commits in Pijul, they are called patches. And we get an editor screen that says this is a message. You can change changes if you want. The authors, this is just for purposes. These are the dependencies. So the dependent patches that I was talking about. This is the hash in Pijul. It's not. So it also uses other letters like A until F. So you can have more hashes and less chance of any hash collisions. And these are the changes. And if from this file, I delete one of these changes, so they will be numbered like 1, 2, 3. If I delete one of them, it won't be included, but it will still be in your working copy, so you can add it to a next patch if you want. In this case, I'll just add it right here, and the patch has been recorded. And if we just ask the log right now, there's the initial patch that we created. Okay, we're going to create a fork. I call it next week. In Pijul, you don't have branches, you have channels, but they are the same concept actually. And if you fork, it will create a new channel like this. If we just ask Pijul channel right here, we see a main and we see a next week. This is just like in Git actually. And now if we would create a file movies.txt, here it is, and we'll keep track of movies that we saw last week. So last week I saw Django Unchained, which was a long time coming. I had to watch it earlier. I think it's from 2010, something. Sorry, doesn't really matter at this stage. So let's do Pijul add movies, Pijul record -m watched a movie. Now, what I now want to do is add another movie and show you this concept of dependent patches. One of my favorite movies of all time is Walk the Line because it's about a musician. I like all movies about musicians actually. Have misspelled it, but it's not really a problem for this demo. Add movies txt, record it again, record. I can pass -a to skip that record screen if I want. Watched another movie. Another movie. Here we go. Now if you go to the Pijul log, we will see watch another movie, watch the movie, and initial patch. Right? Okay. And if we now, the one I have to remember is this one. So let's copy it. And if we now switch to the next week channel, and we say Pijul log, we'll still be at the initial patch. And now I want to apply the watched another movie patch to show you the dependent patches mechanism. So I tell Pijul to apply the patch, this one. And it just says okay. And when I ask the log again, you'll see that it has applied 2 patches actually. The dependent one also, because if we don't have a movies txt, how can we add a movie? So that's how it works. Very short demo, sorry about that. I'll just return to the slides again and wrap everything up. Here we go, I guess. Yeah. So of course I could show a lot more about Fossil and Pijul, but this is just a comparing talk, so I have to be a bit quick. The current status of Pijul is actually quite okay. I mean, it's been in a 0.x version status for a long time, but right now it's in version 1.0 beta, which means that it's stable right now. It's being stabilized, so it's feature complete. So in a few months or so, there should be a final stable version. And it's backwards compatible right now, so lots of exciting stuff. I think it's promising, but it needs some work in its beta phase. They're still working on some documentation things. So the popularity will be based on the stable versions later this year. Back to our predictions. I'll skip to the prediction variables because I think you remember them still. These were our 4 prediction variables. And I'm going to score our new version control systems based on these ones. So I think Pijul's features are really interesting because of this patches and identity thing. And I also like Fossil's features quite well. I think Git and Mercurial will have the upper hand in hosting, but because their hosting is superb, and Fossil and Pijul can be hosted, but it's only a single one, right? Needs to become a bit more popular. I like the open source stuff at Pijul. With Fossil, this is a bit harder because it's suited for small projects and not large projects. And this is the wet van de remmende voorsprong, the dominant variable. Git and Mercurial will suffer more from that. So if we add everything up, I think TFVC will probably die quite soon, not really sure, but Fossil will be like the same. I think Pijul will rise a bit in popularity, but it needs to become a bit more famous, you know. It's not really famous right now, but maybe it will be. So if we would express this in a few numbers, these were our first predictions, and with the things that we've seen until now, I think maybe we will see these numbers in 10 years' time. I don't think Pijul will take the market by storm, and Fossil also not, because it's for small-scale projects, but it could be a good fit for your project, who knows. And Pijul, well, it's very much depending on whether the larger platforms will start supporting it. But you can use it right now with its own Pijul nest. So if GitLab or something or GitHub will say we will also support Pijul repositories, well, then it can go fast. And if they never say that, then maybe it will never become popular at all. But there are interesting projects to check out and to see if they work for you. If you really like the topic, you can read these things. I've read them to prepare for this talk, so you can check them out. And as I said, the slides will be, I'm going to skip a few slides here. The slides will be at the Pijul Nest link right there. So if you want to see them, or if you want to use a Docker file that I created to test out Pijul, you can. Yeah, the only thing I want to tell you as of this moment is try FOSSO for a change if your project is nothing like the Linux kernel and it's on a small scale and you want to try it out. And if you've got problems in your team with Git snapshotting, stuck in a rebase, stuck in a cherry pick, I'm not sure, I've heard these stories multiple times, you could try Pijul for a change because you won't have that with Pijul. Thanks for your attention. I hope that was useful in some way, and have a great day.